So we'll get started. Our next talk is by Thomas Ballinger and entitled Finding Closures with Closure. Please welcome him.
Hey, thank you. Hi. So a friend of mine was asked what closures were at a programming interview about four or 5 years ago now. And this is a pretty competent kind of JavaScript and Python programmer who really froze up at this question. So can I ask who would feel, if someone asked you in this programming interview question at what are closure, what is a closure, who would feel kind of comfortable saying some things for a bit, I guess? They could do, okay, so some. So I hope today we come away, some of the closure we want is being able to say some things to that, whether you have a top of your head correct definition, at least you could respond a bit. And then another thing is I worked for several years at a kind of programming retreat where I would talk to a lot of people that were pretty experienced programmers who were either coming to Python again after maybe 10 years of being away from it, or coming into Python from maybe some more functional languages or maybe JavaScript. And they would ask me, does Python even have closures? I'm kind of confused. So do you have closures? Like, how do they use? I tried to do this thing. It didn't quite work like I thought it would. So that's something I'd like us to be able to kind of figure out as well. Spoiler, one other question. Spoiler is, the other question I get are, right, does Python have closures? And we're going to come away with yes. Yes, it absolutely has closures. It totally has closures. But we'll discuss the variations of that answer. So to get there, we're going to talk about how free variables are resolved in Python, how Python determines variable scope, and then we're going to take this history through Python's journey or evolution with respect to scoping issues. And then finally, we'll talk a bit more about how we use closures. So say I have two functions, and they're both for formatting strings. But one of them is for HTML, and the other one is for terminals. In terminals, you use ANSI escape sequences to make things red, like your tests are red, and you can make them bold, too. And in HTML, we put these little tags. You might have seen them before. I'm going to import these two functions. So let's do that. Let's bring up our Python interpreter and import these functions. I have to use this from import as syntax, because they both have the same name. And then we're going to use this inspect module, it's in the standard library, for looking at the code of these functions, the source code. And this one's relatively simple. It's this one line kind of, let's just slam these strings together. And then this other one looks remarkably similar, right? If we actually look at those together, they're the same. They look like the same function, right? That's the same text there. And yet I'd assert that when I use them, they're going to have this different behavior, right? These are our beautiful ANSI escape sequences, if you know terminal, exciting terminal stuff. And like, how could that be? How is that possible? These really look the same, but they have this different behavior. And instead of answering, we're going to talk about something else, but we'll come right back to that. The way that's possible, well, another question that we could ask if we're looking at this. So this bold before here, I'm going to call it a free variable because it's not a local variable. It's not something that's a formal parameter. It's not text there. And there's not a local variable we assign to in that function. So if we were to go back to if we look at this and we say, what is this going to do? Pop quiz, what's going to happen if I stick that function call, let's see, down here, this function call, I'm calling that function that uses that variable, and before, I'm going to change what before bold is. I'm going to make this new local variable. And the question is, what is the behavior we'll get down here, right? Is that function that we saw before, is it going to use that new value, that in Sharpie, or is it going to use that original behavior? And this question is really about whether the Python language uses open free variables, where when you don't know the value because it's not a local variable, are you going to determine the value of that variable by looking up the call stack? Are you going to say, well, who called me? Do they have that variable? Well, who called that? And going up like that. Or are you going to say, we're going to use the value in the environment where I was defined? In this 1970 paper by Joel Moses, he points out, it's a paper about implementing both of these systems. If you look up the stack called dynamic scope or lexical scope, if you go back to the environment where it was. And he's saying, implementation-wise, we'd really like to do the look up the stack. It's easier to write an interpreter or compiler that works like that, but the programmer probably wants to use the variables in the environment where they define the function, not the new variables that the user of the function has made. So with that in mind, the programmer would usually prefer that behavior of using the variables in the environment where the function was defined. This is for everybody now. What do you think this is going to print? Is this going to be the old bold tags, the original behavior, or is this going to print in Sharpie? Bold tags, great. A little bit of confidence there. All right. Yeah, it's absolutely going to be the bold tags. Now, what if we did something else? What if we changed the global variable here? I'm going to import the function from another module, and then I'm going to change this global variable. I'm going to say before bold is now in Sharpie. Now what is this going to print? Is it going to be the original bold tags, or is it going to say in Sharpie? But it's going to be bold tags again, because this, yeah, I changed that global variable here, but that's a totally different global variable as the one that we used here. And well, let's finally look at the code for these functions. So indeed, they're similar, these modules, HTML format and terminal format, but we can see that they have these different global variable values. And the fact that I can say that, different global variables with the same name, suggests that global is not a good name, right? So global variables in Python, not global at all. That's not a great name. But since we're kind of stuck, really they're module level variables, right? Variables kind of like static in C or something. They're shared by all the functions in that module. But since we're stuck with this word global, maybe we should imagine them as existing on kind of separate planets, right? So global means within that globe, yeah, it's global, right? There's only one on that planet there, but we're kind of stuck there. And now when we import a function from there, that function is like an emissary from that planet, and it has a live communication link, right? It talks to that planet and uses the environment there. So it talks to its home world, and it has the constant link there. So if we're going to have it work that way, well, the way that it works is that Python functions have, this is a function object here, bold. Not only does it have an attribute, which is the string of the module it came from, but it actually has the actual namespace of that module sitting there on it, right? So this globals.keys says, oh, here are the variables I know about. And in fact, that is object identity, the very same mapping as the one you get when you ask for the namespace of that module. That's what vars does, this built-in function. So this is it's a very same namespace, and Joel, our friend Joel, back in this paper, he talks about, all right, one way you could implement this behavior that programmers would prefer, which is where functions look up their free variables in the environment where they were defined, is you could have the code, but you could also have some environment, and you want to stick those together. And the thing that we're going to call that when we stick them together is a closure. A closure is code plus environment kind of tied together. So far, Python functions are looking an awful lot like closures, right? They have code, and then there's an environment attached to it somehow. So because that's a live link to that module, right, we can take this code, stick it at the bottom of that module, and, well, I'll ask you, if I run this here, this is now the new module code. I've changed those global variables to the bottom, and now I'm going to import that function, call bold on it. Are we going to see that bold tags or the new classier, like, CSS is happier span tags there? Span, yeah, because we've changed that global variable. It's not about the value when it was defined. It's about the value when we call it. So let's walk through that code. We go in there, we import that module, we define the global variables, we define the function, change the global variables. Now it's going to be that new value. How about if we modify those variables outside of the environment? We can take that module object and actually access it directly. Python lets us do that. And we can just change this. So now I guess before, I suppose it was for someone writing kind of a sign at PyCon that you see. And now I guess this new bold function is going to be for an airplane. So if airplane's flying, you can't really bold the letters because it seems like they always have one font. But now it's going to say read this. And I'm asking, is this now going to say read this, or is it going to be those old span tags? Or bold, they read this, right, because we're changing it. So one more time, it's about the value at the time that the function is called, right? So this distinction between function definition time and function execution time is really important because of that live link behavior. And some things happen at function definition time, some happen at function execution time. One of the things that happens at function definition time is that Python analyzes our code and determines the scope of each variable. So when we're identifying the scope of a variable, this is something that we're probably we might already have good programmer intuition for. So let's try this ourselves a bit. The process is that Python, we might say compiles, but we'll just say defines here. We make this function object somehow, and all these attributes on it have the different information about the function. So some of the best information is on this dunder code object. So we're going to look at some of the attributes on here because that's where Python puts information about how it processed the function, how it defined the function, how it compiled the function. So for as long as Python has been on the internet, which is 25 years at least, I think, there have been at least two kinds of variables. There have been local variables and these phone home global variables that mean go get the value when we call the function. I mentioned you already have this intuition, so let's be the interpreter for a moment. Let's try to figure out, of the variables in here, this is a great function for blockbuster movie titles, if that's a problem you face. Let's try to figure out whether the variables in here are local or global variables. So first up is phrase. Is phrase in here a local or global variable? Local, yeah. Is capitalized, is that a local or a global variable? Local. So this function has only local variables in it. It's interesting because that kind of means, so one's a parameter of the function, right? One is assigned to in the function. Both of those things make them local variables. This is the kind of function that we might call a pure function. It doesn't really need that attached environment. We never go look things up there. And this brings us to one of our first forks in this definition of closure. Is it still a closure if it has attached environment, but Python never looks at it because it doesn't need to? Python doesn't compile, or at least CPython doesn't compile that link to the module away, so it's still code and environment, but it never needs to use it. So this is the first kind of many times that we have to figure out which one's a closure and which isn't. And besides that, in a little bit, stay tuned, we're going to find out that most people would not call either of these functions closures. And we'll get there, so stay tuned for that. All right, next up. Next up, let's try to be the interpreter for this one. Did I just give the answers? No. These are the answers. This is where you can find the answers on that function object. Let's try another function. This is coming up with catchy phrases, I guess. Or maybe if your phrase is catchy enough. Is phrase local or global? Okay, is options local or global? Yeah, is a default title local or global? It helps because it's all caps. That's a convention in Python. Doesn't really matter, but how about catchiness? Is that a local or global variable? Yeah, it's local because, well, no, not local at all. That's global. Nowhere in there do we assign to it, right? It's lowercase, but that's not the important part. It's that we never assign to it in that function. So let's check our answers. Indeed, we're going to find that the local variables and that co-var names, and then co-names is a bunch of stuff, but one of the things in there are the global variables. All right, so far our programmer intuition has kind of agreed, but we're gonna see a function now where your intuition about what the author meant might not agree. We have a global variable called high score, and it looks like this function's supposed to change that high score somehow, but if we go through, is high score a local or a global variable here? Yeah, it's local. It's kind of unfortunate because it's called new high score. It's maybe supposed to switch that. So what error, anybody know, will we get when we run this function? Unfound local, yeah, great error, excellent error. So that's because the classification of high score didn't go as we had hoped. Yep, it's local, right, because it's up there. So we need to tell Python to skip that heuristic. Don't use that heuristic of was it assigned in this function, just make it a global variable anyway. So we have this global keyword for explicitly saying that, and now this code works kind of as expected. We can assign back up to that scope. All right, so far we have gone through maybe kind of two big kind of fundamental things, one of which is that in review, so the scope of a variable is determined at definition time, and the other one is that the value of a variable is determined at execution time. And if we're feeling okay with that, then, well, congratulations, you're now a Python 2.0 scope expert. That's all there is. This is cutting edge technology in the year 2000, right? This is, we kind of looked at everything there is. But in Python 2.0, there's an important method of closing over free variables that wasn't available to us. One that's required by most people to call something a closure. So many people would say, none of these are closures yet. Yeah, sure, you were accessing that global environment, but that doesn't count for reasons unclear by that original Joe Moses paper, but in the intervening years, we've made changes to the definition of closure. So let's take a look at this function. It might be, you might recognize it if you know an excellent talk by Ned Batchelder about looping, but here we're going to use it as an example of why that wasn't quite enough scopes. We've got these buildings, and then we're going to try to find the tallest building here. We're going to find the max of the buildings. The way we determine max is not alphabetically or something. It's going to be this local function height, and this just looks in that dictionary to grab it. Now, if we're being the interpreter in this local function here, is name a local variable or a global variable? Great. Is buildings a local variable or a global variable? This is a trick question. Right? Because it turns out, it so happens that in Python 2.0, it's like, well, I don't see it local, I guess it's global, but we really would like it to be that outer scope, right? So at this point, we need some kind of other scope In fact, how about what error? Well, I just told you, it's going to be this global one, right? Global name building's not defined. We need a new scope, and we can find evidence for it in here. It's going to be called co-free-vars, or where we'll find it on the function object. And this is when we want to bind to an outer scope that's not the global scope. And not the local scope, not the global scope, somewhere in between. So this was optional in Python 2.1, and then in Python 2.2, it was just required, and variables from outer non-global scopes are always found in that free-var spot. This is what our function looks like, that height function, once it starts working, once we move to 2.2, or we do the future import in 2.1. And now that we're talking about, we've covered all the scopes, we're set. This has got to be, these are definitely closures now because we're binding over any one of those outer scopes. But the implementation does get a little funky here, right? With modules, we just had that namespace. It's even a thing we can reach out and touch and modify. But usually when people talk about closures, they're not thinking about the module level scope. And I think a lot of this is because the module level scope is kind of easy. Python modules are sort of singletons, right? You import it, you've just got that one. There's only that one scope. But once we start trying to save all those other scopes, like a function can be run many times, right? And each time it could produce a different set of those mappings. And each of the functions that has reference to that will need to, well, every time we produce a function that has reference to that scope created by the function running, we need to save it again. So let's look at a tricky example that has trouble. People have trouble with scopes with this in general. Let's make a bunch of format functions. For each of the colors, red, green, and blue, let's define a function that colors text that color. Great, we're going to stick them in that dictionary. Now we pull out the green one. What color is hello going to be? We're not, yeah, green's a good guess. Blue is a better guess. Maybe it's easier when we say print color here. What's the value of color after the for loop? Blue, it's right. The first time it was green, red, then green, then blue. By this point, it's blue. All three of those functions, it's not a local variable, so it's a global variable out there. They're all using the same global variable. So we're going to end up with 3 functions that all output in blue. And so the solution to this is to build a new scope, right? We wish that we could have each of those functions have their own mapping, if each one had its own mapping, we could set each mapping appropriately. And so that's our goal here. Each time makeColor function is called, we get a new local mapping, so each color will be different. And a function called inColor is defined, which references the color variable from that outer scope. There was a local variable there. And we stick it in the dictionary. And now we have to think of it as, we've still got our global scope planet, but these were maybe kind of 3 little moon scopes here, because each of those functions, yeah, they had the global scope, but they also had their own little scopes. But those scopes aren't things like the global module, like a module that we can reach out and touch. Those are kind of hidden from us. We're not going to talk much about the implementation of this, except that I've pointed out it might be a little interesting. Our hint about it is that there's a dunder closure attribute on functions. If you look at that and some other things, you can kind of learn about how this is implemented. If you read the PEP where they implemented this, there's some interesting things, different ways they could have implemented it. But now we've reached the most common definition of a closure, which is a function with free variables that are closed, the free variables of the function are closed by outer non-global scopes. It doesn't count if they're global, because that was too easy. However, another fork in definitions occurs here. So we had these 3 color functions, and before that, I forget already, but we had this tallest building one, and some people would say this is not a closure, and these are. And that's because in here, you could tell, like the make color func was done running by the time we called that function. So it was clear that somebody somehow was preserving those mappings. But back here, we called this height function inside the scope of tallest building. So you could use a kind of more dumb implementation that just looked up the stack or that somehow used the previous bindings. I'd like to call both of these closures because they're both implemented the same way. One gives us more evidence that it's a closure, but you can also read the Python source or look at these objects and find out that, yeah, they all have that link, that closure attribute. But we'll encounter more of those kind of forks about what it quite means. So the distinction, right, looking up the stack. So now we're at Python 2.2, right? Definitely closures now. We absolutely have closures. If anyone's asking, oh, does Python have closures? Yeah, we totally do, right? There's no ifs, ands, or buts about this. Maybe there are a little bit, and we'll have to get to those. But congratulations, nothing important happens in Python scope till 2.7. So you're all now Python 2.7 scope experts. Again, cutting edge technology in the year 2008. But if kind of rumblings of the inefficiencies of Python 2's closures have ever reached your ears, you may not have closure yet. You may be thinking like, wait, but I tried to write this code from JavaScript and it didn't quite work. Or I heard someone say that Python has weak support for closures or read-only closures, but they're not full closures. And this comes from this asymmetry between kind of the global variables before and these non-global outer scope variables that we have now, in that we can't specify a variable that we want to assign to in that outer scope as belonging to that outer scope. And when we make a variable in this inner scope, it's going to look like a local variable. We'll look at an example here. Here's an example of where you might want this. Let's walk through this again. We're going to be the compiler. In this inner guess function, is n a local variable or a global variable? Or another new option now, is it an outer scope variable? I'll just call it outer. But n, local variable, global variable, outer scope variable. Local, yeah, great. Answer, is that a local variable, a global variable, or some outer scope variable? Outer scope, okay, yeah, because it's a local variable up there, and down here we never assigned to it, cool. Last guess, what is that? Local, global, or outer scope? Oh, we'd love it to be an outer scope, but it's not, unfortunately, right? This is the error we're going to get if we try to treat it like an outer scope. I should have asked you what error is that going to be, because it's this great unbound local error again. The problem here is that we used assignment on it, right? Down here on last guess, we said it equals something, and that makes it a local variable, and we wish we could fix that. We wish that we could specify it. So we need the analog to that global keyword. So we get that, it's non-local. We fix this, we put non-local there, it works like we expect. So this is Python 3 now. So if we're in Python 3, we can do this, and we might call these rebinding closures, right? We can actually change what that outer scope variable is. Now before, we could still send messages to that thing. If that thing were a mutable object or a class or something, or an object, we could call methods on it, we could mutate it, but we couldn't rebind it. So if you're going to have last guess equals none, we were never going to be able to make it not none. And now we can. We can say last guess in that guess function, I'm talking about that outer one. You can kind of see what guess does here. I think that's less important. But it's definitely a closure because it's binding over that outer variable. Okay, definitely closures now, right? These are definitely closures. Also, by the way, you're now a Python 3.6 scope expert or 3 point whatever, because that I know of. No big changes have happened to scopes. So what's left is how closures get used in Python. They're used all over the place. Anytime you're wondering if something's a closure, by that outer scopes definition, you can look for the closure attribute on it, that dunder closure thing. If it is, it's closing over those outer non-local scopes. Here are some of the places they come up. So inner functions are often using variables from outside that inner scope. Lambdas usually are. All these places in the standard library where you need a callback, where you need a function, if that function's going to do anything interesting, then it's probably changing some state somewhere, and a common way to do that is with a closure. Decorators deserve their own slide because this is so common, right? A decorator is always something that takes a function and then usually returns a new function, and that new function usually has a reference to the old function so that it can be generic somehow. In this case, this terrible retry decorator just tries to do something and then catches the exception. But you can see func, right, is a local variable in the retry scope, and then, so this is definitely a closure because it's referencing that outer scope. And by even the stricter definition of, and the retry has to be done running, right? Decorators run at compile time, or at function definition time, and then they're done. So those scopes are gone and have to be preserved somehow, certainly a closure. One more aspect that I kind of want to find closure on is how did we get along without non-local for so long, right? Many people still use Python 2 code. How do they survive without this non-local keyword? It took us 9 years between Python 2.2 and Python 3 to finally get this non-local keyword. If it's such an important change, why don't we see a ton of Python 3 code using it now? So now what follows are kind of some thoughts on maybe why this isn't as important in Python. A lot of real-world examples do use the pattern of nonlocal. They're just trying to maintain Python 2, Python 3 compatibility, so they can't use it. So this is a real example, quite abbreviated from the Django code. Here we've got this variable root in that outer scope, and we'd really like to change it. But you can't change variables like that in Python 2. So what we do is we wrap it in the simplest mutable object we could think of. And then down here, we assign this little bit more cumbersome syntax of saying nonlocal root, the thing in there, I want you to change that. And this is it's not elegant, but it's not so bad. And I think many times when we could use a closure that can rebind that outer scope, something like this works. And this is the kind of the most ridiculous case where they're calling it non-local, right? They're just waiting for that refactor when we go in and change it. But sometimes there's other ways you can express this, and you can always come up with something similar by sending that message to that mutable object that it should change. So another reason is we already have modules, and we already have a global keyword, which lets us change those module singletons, kind of. But I think a bigger reason, we don't see it a lot, is that we have a great object system in Python. And if we have something like this, as an earlier example, instead of having to write that local function, we can instead say, oh, the key is buildings.get. And what that means is that you're going to take that get function, kind of build a method out of it that refers to the buildings thing. And in this case, buildings, right, is this built-in Python dictionary, and get is a method that will get the data out of there. So this works kind of well for our previous example. That wasn't mutating anything, but buildings.get could be a method of any kind. And then when things are methods, that kind of telegraphs to you that, like, hey, I might modify that state. So you end up with something maybe, someone might argue, more readable because, all right, you have the object and a method on that. When you pass it in, the cool part in Python is it remembers which object it's attached to. So maybe a reason we don't use non-local there. And then I want to posit a cultural reason, which is that Python programmers we tend to be comfortable with private data being externally accessible. I think Python and JavaScript are two relatively similar in many ways languages, which both lack, or at least at some point have lacked, an ability to have private data in their objects. They both have these kind of full rebinding closures that you can use to hide data. And there's this pattern we're about to look at that is totally possible in both of these languages and is really commonplace in JavaScript and isn't in Python. So let's look at that. It's going to be a bit of code. But if you have, say that you want a person to have some methods and some hidden data, we could in Python make a person class. It's really simple. And then I have this alternate constructor that takes some private, or it's local data here, name and age, these local variables. We're going to make a person, and then we're going to write some functions, one with a lambda syntax, one with a def, because it doesn't really matter which in Python, right? They're just sugar for each other. But both of these access these local variables, and then we just slap those as attributes onto that object, and we turn the object. So now we have this me person object. Apologies for using person. That's a terrible example, but I have a birthday that we can call, but we can't access my age because it's not an attribute on there. And this really is used a fair bit in JavaScript. It's like, oh, this is clever. We can hide the data in this closure. And I don't know what that's about quite, but every year I've come to Python, people talk about, it'd be OK if you can see those attributes. Just use an underscore to indicate it's not part of the public API. So it's like a reason maybe why we don't do that as much. OK, so we need to wrap up. We need to get our closure quickly. I think it's fine that we don't use those rebinding closures so much. We have alternate ways of expressing things. We should be using non-local where appropriate in Python 3 code. It comes up some. We don't need to search out places to use it, but like that Django example, sometimes it's a natural way to express code. It would be nice not to use that mutable object hack. What are closures, and does Python have them? Yes, Python has them. We'll skip to that one. But closures are the combination of code and environment, and all Python functions are that. Sometimes we say closures only count if they refer to variables from an outer scope, or if they refer to variables from an outer non-global scope. It doesn't count if it's global, because that's too easy. They preserve mappings that have gone out of scope, because that proves that they're being preserved in some cool, interesting way. And maybe they even have to rebind outer scope, those non-global variables. But I kind of like the closures refer to these variables from an outer non-global scope. That's plenty for me. If you're asked, does Python even have closures? You could say something like this. Yeah, Python functions can absolutely refer to variables in outer scopes, even after those variables themselves have gone out of scope. So maybe you could memorize that and just spout that out. But I think it's nicer to have a conversation about, that's interesting, you say closures, now do you mean blank, blank? And then I think that's maybe more what the interview is looking for anyway. Does Python even have closures? Yeah, absolutely. Maybe you can add this afterthought, like, yeah, since Python 2.2. But most of us, when we're explaining our languages, we don't have to say, well, yeah, but only for the last 16 years, right? Only for the last 15 years. So if you want, you can add that. Maybe if you can make a guess at how long they've been programming. But great. So if you want to find out more, here are things I couldn't get to that I would love to have. Fortunately, I don't have time for questions, but I'd love to take them out in the hall, kind of behind here. I'd love it if you could tell me about how my description of closures is kind of wrong, or if you know something about the history of them, that'd be really fascinating. But I hope I've helped you all find closure with closures. Thanks so much for coming.